slideshow from beginning. Oops. Is that the first slide? Hold on. Okay. This computer is slideshow from beginning. Y'all just see the one with all the information on it, right?
Oh, I see with the slide 1 of 25.
Yeah. See, I don't know why my screens are backwards. You should see the other one, but I don't know how to fix that. So I guess you'll just look at a partial version. I can't. No. 1 second. Okay. So like I said a minute ago, your final project assembly selection is due today. So you need to get that to me. Anybody else need a form? Thank you. And today we're going to go over chapter 15. And then Wednesday we'll do 16, and then we have a test on a week from today on 13 through 16. Then we move on. Do you have your assembly selection, or did you send it to me on Canvas? Final project selection? Were you absent last time?
I think so.
Okay. Here's another package. When you're absent, you should check Canvas because I usually have the lectures online. So there's no excuses for not having something. So turn in the back page, and then you need to go back and listen to the lecture last week that explains about the final project. Okay, but today we're going to move on to chapter 15, more concrete. Next time is roofing. So this is a precast concrete framing system. Precast meaning it's precast. It's not cast in place. I think last time we studied, where you pour the concrete in place. So there's plants where they do precast concrete, and there's advantages to that because you can control the circumstances much better, and you can probably create a more perfect product. The only drawback is that, that then you have to ship it, and concrete's very heavy. But if you're making a lot of elements, like you see those T things driving down the highway all the time for highways, you can make that a lot more efficiently in a factory and then take it to where it needs to be. Let's see. Next slide. The attendance sheet is up here if y'all need to check in. And I need your final project selection. Okay, so then plant cast, precast concrete, the structural elements are commonly reinforced with tightly stretched pretension steel. So we talked about pretensioning last time. That's what they're talking about here, and you can see the steel strands. And they can place it in there and pull it tight and then pour the concrete, and it's a very, you can use less steel that way, and it makes a stronger element. Here is some how they're putting some precast panels onto that looks like a floor system. You can see the holes or the cores in there that they can run piping or electrical wires and stuff through. And when you do it this way, you don't have to worry about the weather basically because all the concrete curing is done in the factory. Then they ship it to the site, and you can put it together pretty quickly, and then you have an enclosed space, and you can finish it out. So it's very efficient. Precast, pre-stressed concrete structural elements. Here's some different types that you would see, and those T's are what you see for highways. That's a very strong element. But over farther to the left, you have the solid flat slab, which would probably be used for floors or roofs. Then you got the hollow core slab, which has the holes in it, which not only make it lighter, but allow you to run things, piping and stuff like that through there. Then you got the double T, which is more of a structural element that can be used for roadways or roofs, and the single T. And you can see in the little drawings, the little dots showing you that's where the steel strands that are running through it. Here's an even bigger picture of concrete beams and girders. Typical types, you've got a rectangular beam, an L-shaped beam, an inverted T-beam, and an ash-toe beam. And you can see all the steel that would normally, that's what these dashed lines are. And you can see that there's like a stirrup or a piece of steel that comes up and sticks out the top. That's so that, and I think there's a picture in a minute, you can bind it to the next layer of concrete, like a floor or something that would stick up into that concrete, and it would all become one cohesive unit. And then, of course, the solid darts are the strands that are going all the way back or through it. And in this picture, you can see some of that stuff on the top there. It's a little bit hard to see. But here's a precast building that's going up, and first you're going to have provide support for the beam and slab elements with these column things that have little ledges to place the concrete on. And you can see some of the walls that are filling in the background there. Here's some more panels that are going to go in. Precast concrete wall panels can be solid, as it's shown to the right, or hollow, sandwiched with an insulating core, meaning that it's, some sort of styrofoam between two pieces of concrete. Makes it a little lighter weight, but also gives it a good insulation value. Come on in. Sign-in sheet's right there, and I need your final project selection if I don't already have it. Other precast elements are concrete stairs, which are easily, especially if you have a multi-story building, all the stairs are usually the same, especially in your exit ways. So you can create those in a factory and then just put them together in the site. You can see how they're doing that here. Anything that's repeated a lot, is probably better to do a precast in a factory, because you can reuse the formwork and all that stuff. Here's looks like a parking garage on the top, and how they might put together a precast concrete building. The vertical support can be provided by the columns and the beams. The choice of the roof and the floor slab elements depends on the span, what's needed. The precast slab elements are frequently also used with other vertical load-bearing systems. So you can see here how it would kind of come together. They've shown you a little diagram. And again, this slides are online, so you can study them. This is a floor panel. It's a double T. You can barely see that. It's so small. But and then the sides come in, and they weld or they bolt them together with the pieces of the steel that are sticking out. Here's a real life one. You can see here is a good shot of how the double T's are going to rest on these little supports. You can see that from underneath, and these are the precast walls, and they've hollowed out or they've blocked out where some windows are going to be. Well, it's like putting together Legos or something. It's good when it's a big repeated element like a parking garage or something, but if you wanted some crazy architectural design, it's probably not so efficient, yeah. But if you're just doing a parking garage or something that's repeated a whole lot, then it is a very efficient way to do it. There's like an inside of a parking garage. You can see the double T's, and you can see the joint between the two pieces there. And they'll probably fill that with some sort of caulking material. And one good thing on a parking garage too, it doesn't really matter if there's little cracks because it's really an outdoor environment anyway. You'd have to seal it up tighter if it was a building that you meant to be inside. So manufacturing of precast concrete structural elements. Here's a plant. You can see the casting beds can be up to like 800 feet long. You know, it's really limited, only limited by how you can get it to where it needs to be. So 800 feet, that's pretty long. You'd have to have probably a ship to do something like that. But, you know, depending on where it's going is the only limits that you really have. And you can see the steel strands in the bed that they're going to pull tight and then pour the concrete. You can see the weld plates, I think, yeah, and the blockouts in some of these. There's the tubes for the hollow core. And then the concrete is placed in that, and it's allowed to cure. Here is a giant inverted T. You can see this before they pour it. You can see all the steel. And we saw that diagram. If you look at this, let me see if I can go back to that other picture real quick. So it's kind of a combination between these two, but you see all this steel. It's a little bit different layout, but then we'll go forward. Go, go, go. And you can see all the steel that's coming through there. And remember, the steel is a strong in tension, and when you have a structural beam or girder, it's going to bend in the middle. So you got all the steel on the bottom to keep it from breaking. Concrete is strong in compression, so up here on the top, where the beam will dip, that's more compression, so there's not as much steel there because the concrete will take care of that. And then you got even more steel coming down following the stress of the bending. Does that make sense to everybody? Any questions on that? Here is the machinery inside the plant. They're cutting the sections, I guess, so that they can ship them. Here you got a bulkhead inserted into the to divide the casting bed into sections so that it'll be shorter. You can, like I said, you can form them up to 800 feet long, but obviously that's hard to ship. So that when they need to have shorter pieces, they'll do this, so that then they can put them together on site once they get there.
Just wondering, but with the weather conditions, with that much amount of steel, like if it were to be hot, would it expand the metal, or?
In this one or the previous slide? Because these are inside.
Just how cold kind of shrinks it up.
Well, if they're doing it outside, they do have to pay attention to the climate. I don't know if they're just putting this together and then they'll somehow drag that inside to pour the concrete, but this is definitely outside, but it's so big.
It's like a big conveyor. It starts outside.
Yeah.
And ends up inside.
That's what I'm thinking. And then, yeah,
How do you know how much reinforcing steel you have to put in on the tube?
the engineer knows that. I mean, you as architects, you'll study that, but you'll never really have to design it to this extent. But you just have to know the theory behind why there's steel there. And then the engineer will do the calculations and tell you, okay, your beam needs to be 4 feet deep and it's going to have all this steel. So we just have to know why they do it, not how they do it. Here's a hollow core casting planks. They're being stockpiled with them. Obviously, they're heavy, so the machines have to pick them up. It's all done by machine. And here they're placing it on the site. And you can see the ones they've already placed before that. And there's a little lip on that beam that it will rest on. Here's some planks. You can have smaller pieces, still with the holes in them that not only make it lighter, of course, but also allow for stuff to run through it. So how do you put it all together? How do you keep it from falling apart? So here's some column-to-column connections. You know, obviously, if you have a skyscraper, you're going to have to stack your columns one on top of the other. And you can sort of see in this transparent one all the steel that's in the column, and then it sticks out, and they'll put a plate on top of that. They'll shim it with another one, and they'll weld all this together. Welding is actually a lot of times stronger than the steel itself, or definitely stronger than a bolted connection, if it's done properly, of course. And then you can see how they stuck them together. This one does have a few bolts in it. Probably it's bolted and welded. And then they'll put some sort of grout or something in there to cover up those, so it looks smooth. Here's another column with the little corbels where the beams will rest on those, and then again you have some weld plates that are on this that they will weld, and then you also got these sticking up so that your floor can, you'll see over here on the next one, I think, how the floor is attached to that. So your columns have the corbels with the weld plates and vertical and horizontal to keep it from bending. And then you got your floors, precast floor things that rest. There's a little weld plate there, or a pad. Reinforcing bars will go across it. They'll rest on here. Then your grout will come in, and that will cover up all of this, the stuff sticking up, so that it'll become one cohesive, because the rebar's going that way, rebar's going that way, and the grout is like the glue that holds it all together. And then you might even come in after that and put a thin layer of lightweight concrete to just make one smooth floor finish, which would really, give it some structure. And as it says in the notes, it increases the fire resistance, the stiffness, because you're actually adding something solid over the whole thing. Increases the acoustic isolation. So precast concrete construction and seismic design, you obviously have, you would think it would start shaking and everything would fall apart. You have to think of that a lot, especially in areas of high risk. And even here with the windstorm, you've got to worry about things blowing. I mean, wind can blow even concrete if it's not glued down. So I have a little video demonstration. Let's see. Get that going. So is there any questions on that chapter? Okay. Last time we kind of screamed through chapters 13 and 14. So I want to go back and do a little exercise from 13 now. We'll do that together. You can pass these around. Everyone sign in? Looks like everyone's here. Okay. Let me get rid of this. So this is, we're going to detail a concrete reinforcing bar. Shown in this larger scale elevation view, shown below is a larger scale elevation view of the left end of a continuous concrete beam shown in figure 1329 of the text. So let's find that. Figure 1329 of the text is obviously in chapter 13. 551. Okay, there it is. It's the one on the bottom. You can see they're showing you how it would bend, what it would be its natural bending tendencies. And then we're looking at an enlarged view on page 551, the left end of this concrete beam. So the structural plans call for a 10-inch wide by 18-inch deep beam with 2 number 9 bars and 2 number 8 bars. 15 number 3 U stirrups are required at a spacing of 7 inches. So make an accurately scaled drawing of the reinforcing bars in the beam using the top bars, bottom bars, and stirrups, drawing them as if the concrete were transparent so we can see through this beam. Give critical dimensions of any hooks and do not show column reinforcing or bar deformations, meaning the little wiggles in the bar. So basically it's going to look like this end, but you're going to draw it to scale. And on this drawing, 1 square equals 2 inches. So you want to try to guesstimate. Do you remember what we learned? How big is a number 9 bar? Anybody remember that? What is the number 9 or the number 5? It's a fraction.
2 and 1/2. Number 5 is 2 and 1/2 inches, and
No.
542. That puts her up.
No, I'm saying how big is the bar, a number 5 bar? Oh, I see what you're looking at. Those are the hooks. They're not talking about that. That's not the size. When you talk about a bar size, it's in eighths of an inch. So a number 5 bar is 5/8 of an inch. A number 9 bar is 9/8 of an inch. So that would be 1 1/8 inch. So you want to try to draw your bars to that scale. So you're going to, let me see if I can draw a little bit. It's hard for me to draw on this thing, but I'll try. Kind of draw what you have. Oops, that's not a straight line. Oh well. Pretend these are straight, okay? So here's your column, and here's your beam. Straight, not drawn crooked. And then if you're looking on the page 551, you can see how the steel is formed. So 10-inch wide by 18-inch deep beam with 2 number 9 top bars and 2 number 8 bottom bars. So what do you? So the top bars, which are the number 9, are going to be. You're going to draw them at 9/8 inch thick, which I will not even attempt to do here, but y'all need to do it. And that top bar will come and it'll curl around like in that drawing below. And you'll only see one of them because you're looking horizontally through it. So you're going to draw this line, and it's going to curve, and it's going to be 9/8 of an inch thick or wide. Now, it also, while you're drawing that already, it says refer to figure 1323, which is what you were talking about the diameter or the hook. So a 90-degree hook for a number 9 bar, I'm looking on page 546, is 9.5 inches. So that's what you were referring to, right? A minute ago? So that's your circle here, and I drew that wrong, so I'm going to undo that. Should be a 9.5 inch radius. Let me try that again. Which I can't do anything to scale on this thing, but y'all have to do it on yours. So it'll be a bigger circle. And then the radius of that bend there is going to be 9.5 inches. See if I can write something. Thought I could do text here. Text it. It's like now I can't get it over to where it needs to be. Technology, you know? Okay. There. 9.5 inches. Close enough. Y'all know what that means. The other thing that this chart tells us is that beyond the bend, which is this part right here, the second diagram to the right of that chart on page 546, it says it must go 12 inches. So the length of this line right here, beyond where it stops bending, should be about 12 inches. I can't move that. Oh well, I'll just write it. Once you get that done, then you're going to draw your bottom bar, which it says on the directions are number 8. So how big are those going to be? If a 9 is 9/8, what is a number 8? 8/8, right. So that'll be 1 inch thick line, which will be half a square basically. So you'll draw a 1 inch thick line at the bottom. And remember, you'll only see one of them because the other one is beyond your view. And then once you get that, you're going to draw the stirrups. Which are number 3s, and they're going to be 7 inches apart. So you're just going to draw your lines at a width of a number 3, and they're going to be 7 inches apart. And that's holding all of this together. I didn't print the other side, but I want you to go ahead and right now we're looking at an elevation of this beam. So, oops, wrong way. I want you to draw like a cross section of the beam to scale. Remember, it tells you the size of it up at the top. It says it's 10 inch by 18 inches deep. So this will be a section of this beam. This is my section. Whoops. I didn't want to do that. This is my section line. So I'm cutting through this beam and I'm looking this way. Everybody understand that? I'm chopping through this. Now this is what I'm looking at. Now I want you to draw these pieces of steel in this part like you're chopping through it. So you're going to see little circles for your 2 number 9 bars at the top. And you're going to see little circles for your 2 number 8s at the bottom. And then you're going to see your stirrups going around it. So draw, that would be the cross section. So they'd have to be the right size. You'd have your circles. And then you'd have your stirrup at the right width, wrapping around all of that. You can keep drawing if you need to. Since we have a little bit of extra time, is there any questions on the final project, which was distributed last time, or if you did not get one, because your selection is due today. If you haven't scanned it to me, you need to give it to me now. Anybody need a sheet? Any questions on it? What's your question? How do you do it? Huh? Well, I want you to go back and watch the lecture. What you're going to basically do is draw. You're going to pick an assembly, which means like either concrete block wall, timber frame wall, light wood frame construction wall, steel framing wall. And you're going to draw it from foundation to roof, like these examples are, foundation to roof. And you're going to tell me, you're going to have probably more detail than this drawing. You're going to draft all the elements are in it, and then you're going to write a 2-page report describing all the elements. Double space, it tells you exactly. So what I want you today is just to tell me what type of wall. Like concrete block, wood frame construction, something, and then in a couple of weeks when it's on Canvas, I'll need to see a draft to make sure you're on schedule. You know me and schedules. So, does anybody else have one that hadn't given me one yet? Signature? Is that what's on your driver's license? And they like that? Okay. Like any other questions on this? I just need the back page because you need the instructions. So Wednesday we'll go over chapter 16 on roofs, and we'll do a little assignment. Oh, I need your little assignments once you're done with those. And then we'll have a test on Monday. I think it's in-class test.
Yay.
Why do you like that? It's still open book, but I mean, it makes it, I think, a little bit more structured. You might do better that way.
Probably.
Oh, yeah. Thank you. I sent out a Canvas announcement for extra credit for either absences, because remember, if you have 3 or more absences, your grade drops a letter. So if you need to make up some absences, there's the skills competition Thursday night at the American Bank Center, and we need judges. And some of you have already responded to me. But Mr. Flynn and Mr. Klepak will be there, and there'll be a sign-in sheet. And if you go there and help for the whole time, I think, what did I say, 2 absences?
Yeah, you can make up 2 absences.
3? What? Well, I have it in writing, so I'll confirm. It's on a Canvas announcement.
It was 2.
I think it was 2. But if you've been here all the time and you don't need that, you just want a boost in your grade, I think I said 10 points. Yeah. So it kind of works out the same either way. 10 points is, yeah. So if you haven't signed up for that, or if you haven't let me know, I haven't gone through and compiled all that since I've been gone, but I know I've seen the emails come in. Either respond to that or tell me now. Did you respond to me already? How about let me do this. If you're going to go, I'm going to pass around this, or come on to the attendance sheet and say, put a check over here for, I'll write skills. And then, of course, I'm not going to give you the credit till you sign in there. But it's at the American Bank Center. The details are on Canvas. I think you'll get a free dinner, which is worth it too.
That alone, right?
But it takes, the more people that help, the quicker it goes. And basically what you're doing is judging drawings from high school students around the state. That's their state competition for drafting. If any of you,
Schools from the local area?
a few, but it's the state competition. And so you go and there's just this giant room as big as this floor. You can wear what you have on. Cool. I mean, don't be all sloppy and it's not a night out on the town. It's a business. like you're going to class.
And
Anybody
we'll
else?
be there all day to get the
All night.
Yeah.
I think it starts at 5:30,
5:30
or
till,
10.
probably 10 or 11, depending on how many people are there.
till it finishes.
Yeah. And if you got, I mean, if you can only come for a certain time, he'll take all the help he can get. But
And you said it's American Bank Center, like is it like a
the convention. So if you,
Downstairs, right?
there'll be signs.
Oh.
Y'all know Mr. Flynn, right? So, I mean, that's all the information I have. Maybe I'll tell him to make more information, but.
Yeah, try to put some sort of something on campus.
Okay.
I mean, if you would like to.
Or a map or something. But if you when you're going there, I know that like you're driving to the American Bank Center and you're going down that road, and there's all kinds of little parking lots. In the past, see, I can't go this year, but in the past when I've gone, there's one on the left, and the American Bank Center's over here, and there's a guy standing there guarding it. And if you tell him you're going to be a judge, then you can go in there and park for free.
Really?
Otherwise, you got to pay whatever the other people are paying.
And how do they know if you're going to be a judge? Like,
They
do
just-
you wear a badge or something? Or?
No, you just say I'm judging the skills competition. So they've never asked for anything else.
The judge.
I am the judge. So you can get extra credit for that by doing that. So, anybody else need to check this for that? You emailed me, or
No, I just don't know if I can go yet or not.
okay? Well, you don't have to decide till then. He wants an idea of who's going to be there. So, all right, that's all. So I need those sketches you did once you're done, and then we're done. So.